to today's class. In today's class, we will be going through the Lewis structure of various molecules and ions. A quick summary of the 4 steps to draw a correct Lewis structure. Number 1, determine the magic number of the molecule. 2, determine the central or parent element. 3, distribute the other element around the parent element or central element. 4, complete the octet of the other element, and if any electrons remain, it should be placed on the central atom. These are the 4 steps required to draw a correct Lewis structure. So let's start with methane, CH4. Step number 1, determine the magic number, which will give me carbon is in group 4, that is 4 electron, plus hydrogen is in group 1, that is 1 electron. So we have 4 hydrogen, that will be 4 times 1 electron. Magic number is 8. Now the central element is carbon. So we are going to have central element is carbon. Our central element is carbon. Then we are going to distribute the other element around the central element. We have 4 hydrogen to distribute around the carbon. So we have this structure. Now we have 8 electrons available. How many electrons have we spent? We have 1, 2, 3, 4. Each of these bond pair is 2 electrons. So the 4 bond pair making 8 electrons. So this is the Lewis structure of methane. Now let's look at ammonia. In ammonia, the available electron is, we have nitrogen, which is in group 5, that will be 5 electron, plus hydrogen, which is in group 1, that will be 1 electron. So the 3 hydrogen will be 1 times 3. So that gives me again 8 electrons. So the central element is what? Is nitrogen. So let's distribute the hydrogen around the nitrogen. We have 2 and then 3, the third hydrogen. Now, how many electrons have we spent? We have 1, 2, 3, 3 bond pairs. Each of the bond pair is made up of 2. It's made up of 2 electrons. So 3 bond pair, that will give me what? 6 electrons. But we have what? 8 electrons available, meaning that there are 2 extra electrons. So we have the 2 extra electrons should be placed on the nitrogen, because hydrogen can only take a maximum of what? 2 electrons. But don't forget that similar charges repel each other. So these 2 lone pair electrons will repel each other, causing the structure of what? Of ammonia to be distorted. So this is what we will have because of the lone pair on top of the ammonia. Now let's take another example. Let's take phosphine. Now the available electron, phosphorus is in group 5, so I'm going to have 5 electron, plus hydrogen is in group 1, and since we have 3 hydrogen, we have the 3 into 1 electron. That will give me again 8 electrons. The central element is what? Is phosphorus. The central element is phosphorus. Then we distribute the hydrogen around it. That will give me, we have an hydrogen here, another hydrogen, then the third hydrogen. Now, how many electrons have we spent? We have 3 bond pair, making what? 6 electrons. 6 from 8. We have 2 electrons remaining, which should be placed on what? On the central element. Now, these 2 electrons will repel each other because, according to Coulomb's law, like charges what? Repel. Their repulsion will distort the shape. So at the end, we will have something like this, just like in the ammonia molecule. So that is the Lewis structure of phosphine. Now let's go to boron trifluoride or boron fluoride. Now the available electron, boron is in group 3, that will give me 3 electron, plus fluorine is in group 7, that will give me 7 electron. So what do we have? That the total will be 24 electron. Now the central element is boron. I told you that in any molecule, the first element that is not hydrogen is always the central or parent element. Is the central element. Let's distribute the fluorine across, not across, let's distribute the fluorine around the central element. Now fluorine obey octet rule. That means it takes 8 electrons. Only hydrogen and helium takes what? 2 electrons. Every other element takes what? 8 electrons. Now each of these fluorine just have 2 electrons. We need to complete the electron to become 8. So we have to place lone pair electron on the chlorine atom. So this 6 electron plus these 2, making this fluorine to have what? 8. We'll do that for the rest. Now, so how many electrons have we spent? 8, 8, 8. That gives us what? 24 electrons. So this is the Lewis structure of boron trifluoride. Let's look at beryllium chloride. Beryllium chloride. Now, the available electron in beryllium chloride is, beryllium is in group 2. That will be 2 electron plus 2 into 7 electron for chlorine, making a total of 16 electrons. So the magic number is 16. The central element is what? Is beryllium. So let's distribute the chlorine around the beryllium. Around the beryllium. Now chlorine will be octet rule, so we complete the electron to become 8. So 8 plus 8 making what? 16. This is the Lewis structure of beryllium chloride. Now let's look at carbon 4 oxide. Carbon 4 oxide, CO2. Available electron. Carbon is in group 4. That will be 4 electron. Oxygen is in group 6. That will be 6 electron. So the 2 oxygen we are going to have times 2. So that will give us what? 16 electron. The central element is carbon. We have to distribute the oxygen around the carbon. Now let's complete the octet of the oxygen. Make the electron to become 8. And let's make this to become 8. Now this is not the complete Lewis structure of carbon 4 oxide. The reason is that all elements that have oxidation state of plus or minus 1 form only single bond, plus or minus 2 form double bond, with oxidation state of plus or minus 3 form triple bond. Now you know that the oxidation state of oxygen is -2. The oxidation state of oxygen -2. That -2 implies that oxygen can form what? A double bond. Now why do we need this? If you look at this, oxygen can form a double bond, but look at the carbon, the central element. It has 2 bond pair, making what? 4 electrons. And you know that carbon obey what? Obey octet rule, which means the number of electrons on the carbon has to be what? 8. But oxygen can help because it can form what? A double bond. So we are going to convert what? These 2 electrons to a bond pair, and these 2 electrons to a bond pair, because the carbon needs 4 extra electrons. So let's have a structure like this. Now we have a bond pair before. If we convert this pair electron to double bond, we have double bond here, and we have oxygen where we have 2, 2. Now if we convert this to this, we have double bond here where we have another oxygen. So this is the what? the correct Lewis structure of what? Carbon 4 oxide. Now let's look at sulfur 4 oxide. Sulfur 4 oxide. Now sulfur 4 oxide available what? Electron. That will give me sulfur is in group 6. That's what? 6 electron plus oxygen is in group 6. That's 2 into what? 6 electron, giving me a total of 18 electron. So the magic number of sulfur oxide is 18. Now sulfur is the central element. Let's distribute the oxygen around the central element, and let's complete the octet. Now we have this oxygen has 8 electrons. This oxygen has what? 8 electrons, making what? 16. 2 electrons is remaining, which goes to the sulfur atom. Now look at the sulfur. Look at the sulfur. You discover that the sulfur has 2 bond pair and 1 lone pair. The 2 bond pair is 4 electrons. The 1 lone pair is 2 electrons, making what? 6 electrons. Now sulfur supposed to be what? 8 electrons. Sulfur supposed to be 8 electrons. Now each of the oxygen can form a double bond, meaning the first oxygen can form the double bond because the sulfur still needs what? Extra 2 electrons. So we can have this electron converted to what? To bond pair electron. So we can have something like this. Don't forget, the shape will be distorted because of the lone pair. We have this, and we can have just this as normal as it is. Or we can have the other sulfur contribute the 2 electrons, whereas this one does not contribute any electrons. So which means that sulfur 4 oxide can have what? 2 structures. Now let me still go through something that some of you might have been asking the question quietly. Iodide. Now the available electron, beryllium is in group 2 plus 2 into 7 because iodine is in group 7. That will give me a total of 16 electrons. Now the central element is what? Is beryllium. So I'm going to have beryllium. We have 1 iodine here, and we have 1 iodine here. Let's complete the octet of the beryllium. Now, how many electrons have we spent? 8 plus 8, making what? 16. Now, look at the beryllium. Beryllium obey the octet, that is 8 electrons. Beryllium only have these 2 electrons plus 2, making 4 electrons. But the problem is that we cannot convert any of the electron on the iodine to a bond pair. The reason is that the oxidation state of iodine is what? Is -1, meaning that iodine cannot form a double bond. So we cannot convert any of the electrons on what? On the iodine to a bond pair. So this compound has to remain like this because iodine cannot form what? A double bond. Now let's take, for example, let's take ions. Let's have ammonium ion. Now available electron will be nitrogen, give me 5 electrons. Hydrogen will give me 1 electron. For the 4 hydrogen will be times 4 minus 1 electron because of the +1. That will give me a total of what? 8 electrons. So we will have N. Then we distribute the hydrogen around it because its parent element is nitrogen, and we have it like this. Now how many electrons have we spent? 1, 2, 3, 4. 4 bond pair give me what? 8 electrons. But because this is ion, the entire bracket, the entire structure must be in a square bracket. Then we add the +1 there. Now let's look at carbonate ion 2-. Available electron is carbon is in group 4 plus oxygen is in group 6 plus the -2 means it has gained extra 2 electrons. Everything together we will have 18 plus 2, plus 4, making what? 24 electrons. So the central element is what? Is carbon. Let's distribute the oxygen around the what? Around the carbon. And let's complete the octet. Because it is an ion, we will put the entire structure in a square bracket. So we have spent 1, 2, 3. We have spent what? 24 electron. Now, if you know the carbon, which is the central, if you take note, the carbon, which is the central element, has how many electrons? 2, 2, 2, making what? 6. Fortunately for us, each of the oxygen can donate what? A double bond. Because each of the oxygen can donate a double bond, we can convert this 2 electron to a bond pair, or from this to a bond pair, or from, so which means we can have 3 structures, of which I will just draw only 1 here. Now we will have C double bond this, and this. So this is one of the structure out of the 3 of the structure out of the 3. So this is how to go through Lewis structure, and we have covered all possible scenario of Lewis structure. Now one more example, and that is what? I3 minus. Now available electron will be 3 into 7 electron plus the 1 electron that is because of the -1, that means an extra 1 electron is gained. That will be 22 electrons. Iodine, so one of the iodine will be the central element. One of the iodine will be the central what? Element. So we distribute the order around it. So let's complete the octet. Now, how many electrons have we spent? We have spent, this is 8 electron, and this is what? 8 electron, giving us what? 8 plus 8, 16 electrons. 16 from 22, that will be 6 electrons. So we are going to have 3 lone pair. This is 1 lone pair, and this is the other lone pair, and this is the third lone pair. So this is the Lewis structure of I3 minus. Thank you.